Okay, tangent lines. Our goal on this problem is to estimate the slope of the tangent line to this graph at the ordered pair 1, 2. So it's already drawn in here, this blue line going across here. It's tangent to the graph because it only touches the graph in that one point. It doesn't touch any other points along the way in this graph. All right, so to calculate that or get an estimation for what it's going to be, what we're going to do is we want to calculate the slope of some secant lines. So the first secant line we're going to look at, I'm going to kind of bring these in here. Thought this was easier than drawing them as I go. Is we're going to use the point we really care about, 1, 2, and then we're going to start with this point way down here, far away. All right, we know how to calculate slopes of lines. Slopes of lines are simply y2 minus y1 over x2 minus x1. So let's use that formula. I'm going to treat this as x1, y1, x2, y2, and that ordered pair at the bottom is the ordered pair 2, negative 1. So the slope of that secant lines intersect the graph in 2 points, is going to be y2 minus y1 over x2 minus x1, which will work out to be negative 3 over 1, or negative 3. Okay, it's an estimation, but I think we can get a better estimation. So what we're going to do is we're going to go from the point that was way down here and pick a point that's closer to the one we really care about. Again, the one we care about is 1, 2. So I'm going to slide in a little bit closer and use this point next. Again, drawing a secant line in, you can see that this secant line intersects the point 1, 2 that we really care about, but it's going to use this point, which is 1.5 comma 1. All right, the slope of that line is going to be a better estimation to the blue one. As you can see, we went from the black line to this one, and notice how it's squeezing in here and getting closer and closer to the blue line. Again, we're going to go back to x1, y1, x2, y2. Calculating this one, let's go ahead and say that slope is going to be y2 minus y1 over x2 minus x1, which is negative 1 over 0.5, which works out to be negative 2. All right, better estimation for what the slope is of that blue line, but I think we can do a little bit better. On this last computation, we've gone from here to where the red line is. We're going to move even closer to the point we really care about, 1, 2. So visualizing what that's going to look like, if I bring this line in, you'll see the orange line is even closer to where the blue line is. And in fact, maybe I'm a little bit off on that. It's going to be tough to pick up on command. All right, just go with it for now. It should, on the left-hand side, be a little bit above where the blue line is, and the right side just a little bit below where the blue line is. All right, so one more computation here, and then we'll make an approximation. x1, y1, x2, y2. And let's say that that point that we care about is at 1.3 comma 1.5. All right, so the slope of that line is going to be y2 minus y1 over x2 minus x1. So 1.5 minus 2 is negative 0.5, and 1.3 minus 1 is 0.3, which works out to be right about negative 1.667 as far as an approximation goes. All right, we could get an exact fraction there, but I think if we want to make an approximation for what we think the slope is of the blue line, notice how we're trending here. We went from negative 3 for the slope of the black line to negative 2 to negative 1.667. If we were to estimate what the slope of the blue line is, I think we have to go a little bit further, but I think this one trends to slope of the tangent line is going to be right at negative 1.5. All right, so I hope this helps out as you're working on finding slopes of secant lines to help estimate the slope of a tangent line.